Langchain Experimental Video Captioning Services Audio Service Audio Processor Summary. This component processes audio from video files for generating captions. It plays a crucial role in video captioning services by converting raw audio into a textual representation that can be further processed to create captions. Inputs. Audio. This refers to the audio track extracted from a video file. This is the raw input that the audio processor works with. It can be in various audio formats such as MP3, WAV, or AAC. Outputs. Text. The output of the audio processor is a textual representation of the audio input. This text can be in the form of a transcript or a sequence of words, depending on the processing steps involved. Steps. Convert audio to text. This step involves transcribing the audio into text. This is achieved using a speech-to-text model that converts the audio signal into a sequence of words. This step requires a speech-to-text model that has been trained on a vast dataset of audio in corresponding text. Process text. The textual output from the speech-to-text conversion is further processed to enhance its quality and prepare it for caption generation. This processing can involve various techniques such as punctuation correction, capitalization, and removal of filler words. Prerequisites. Audio input. A video file or audio file containing the audio to be processed. This audio input can be in any standard audio format like MP3, WAV, AAC, etc. Speech-to-text model. A trained machine learning model capable of converting audio to text. This model can be based on various deep learning architectures and is typically trained on a large dataset of audio and its corresponding transcriptions. Popular speech-to-text models include Google Cloud Speech-to-Text, Amazon Transcribe, and IBM Watson Speech-to-Text. Fine-tune parameters. Speech-to-text model. The speech-to-text model used for audio transcription can be fine-tuned to achieve better accuracy and performance on specific audio datasets. This fine-tuning process involves training the model on a dataset that is representative of audio expected in the video captioning service. Text processing pipeline. The text processing pipeline used to clean and enhance the transcribed text can be adjusted to meet the specific requirements of the video captioning service. This may involve tweaking parameters for punctuation correction, capitalization, or the removal of specific filler words. Challenges and fixes. Challenge 1. Audio quality issues can significantly impact the accuracy of transcription. Noise, reverberation, and other audio artifacts can interfere with the speech-to-text model's ability to accurately convert audio to text. Fixes to challenge 1. Noise reduction techniques can be applied to minimize the impact of unwanted sounds in the audio. Speech enhancement algorithms can improve the clarity and intelligibility of the audio signal, making it easier for the speech-to-text model to transcribe accurately. Challenge 2. Speaker diarization involves identifying different speakers in a conversation and separating their speech. This is essential for creating accurate captions for videos with multiple speakers. Fixes to challenge 2. Speaker identification algorithms can be used to differentiate between different speakers based on their vocal characteristics. Speaker separation techniques can be applied to isolate the speech of each speaker, allowing for individual transcription. Challenge 3. Language identification is crucial for choosing the appropriate speech-to-text model and applying correct language-specific processing steps. Fixes to challenge 3. Language detection techniques can be employed to determine the language of the audio input. Language translation can be used to translate the text into the desired target language. ensuring captions are accurate and accessible to a wider audience. Challenge 4. Transcription accuracy is a crucial aspect of video captioning. Even minor errors in the transcription can affect the overall quality of the captions. Fixes to Challenge 4. Fine-tuning the speech-to-text model on specific audio datasets can improve its accuracy for the target language and audio quality. Data augmentation techniques can be applied to generate synthetic audio samples with different noise levels and speaker characteristics, further improving the model's robustness and accuracy. Langchain experimental video captioning audio model summary. None. Audio file. The model requires an audio file as input. This audio file should contain the speech that needs to be transcribed into a text caption. Common audio file formats, like .wav or MP3, can be used. Text caption. The output of the model is a textual caption that summarizes the spoken content in the input audio file. This text caption can then be used for various purposes, such as providing subtitles for videos or creating searchable transcripts. 1. Audio model processes the input audio file. The model first analyzes the audio signal to identify and extract relevant speech patterns. 2. The model generates a text caption based on the audio content, using a combination of speech recognition and natural language processing techniques. The model translates the processed audio into a human-readable textual description. Hugging face model. The audio model relies on a hugging face model for its speech recognition and text generation capabilities. Whisper is a pre-trained model available on Hugging Face that is specifically designed for speech recognition. It can handle various languages and accents, making it a suitable choice for diverse audio input. Audio file. The model requires a suitable audio file as input, which can be in various formats. .wav. The .wav format is a common uncompressed audio format, providing high-quality audio for better transcription accuracy. Model type. The model type refers to the specific pre-trained model used for speech recognition. For example, Whisper is one model type. Language. The language parameter specifies the language of the audio input. This allows the model to adapt its speech recognition and text generation processes for specific languages, improving accuracy and fluency. Challenge 1. Model accuracy can be affected by audio quality. Poor audio quality, such as background noise or distortion, can interfere with speech recognition and result in inaccurate captions. Use high-quality audio recordings. Recording audio with minimal noise and distortion is crucial for improving model accuracy. Using high-quality microphones and recording in quiet environments can significantly enhance audio clarity. Challenge 2. Speech recognition errors can lead to inaccurate captions. Even with high-quality audio, speech recognition models may occasionally misinterpret words or phrases, resulting in inaccuracies in the generated caption. Employ noise reduction techniques. Utilizing noise reduction algorithms or techniques can help remove unwanted background noise, improving the clarity of the audio signal and reducing the likelihood of speech recognition errors. Challenge 3. Inability to handle different accents or dialects. Speech recognition models may struggle to recognize and transcribe speech with strong accents or dialects, leading to inaccuracies in the captions. Train the model on diverse audio datasets. Training the model on audio data from various accents and dialects can help it adapt to diverse speech patterns, improving its accuracy in handling different variations in pronunciation. Langchain Experimental Video Captioning Services SRT Service SRT Processor Summary. This service processes subrip.srt files for video captioning. SRT files contain timestamps and text for each caption, which are synchronized with the video. This service takes an SRT file as input, parses the timestamps and captions, and then formats them for output. Inputs: the path to the SRT file that contains the captions and timestamps. Outputs: a list of captions with corresponding timestamps. This output can be used to display captions on a video player or to generate other caption formats. Steps: the service first reads the SRT file to extract the contents. Then, the service parses the timestamps and captions, extracting the start and end times for each caption and the corresponding text. Finally, the service formats the captions for output in a way that is compatible with the target video player or captioning system. Prerequisites: the SRT service package must be installed to allow the service to process SRT files correctly. Fine-tune parameters: this service has no fine-tuning parameters. Challenges and fixes: incorrect timestamp format may be present in the SRT file. Fix to ensure accurate captioning: the service implements robust timestamp parsing to handle various timestamp formats that might be found in different SRT files. Some SRT files may contain missing captions, meaning that there is a timestamp but no associated text. Fix: the service is designed to gracefully handle missing captions, either by skipping the missing entry or by providing a placeholder caption. To avoid disrupting the overall flow of the captions, SRT files may contain duplicate captions, which can lead to inconsistencies in the final output. Fix: the service removes duplicate captions to ensure a clean and accurate representation of the video's dialogue. Langchain experimental tot prompts get propose prompt summary. This section describes the overall purpose of the langchain experimental tot prompts get propose prompt summary component, which is to automatically generate effective prompts based on user-defined inputs and desired outputs. Inputs: this refers to the data that is provided to the component to guide the prompt generation process. It can be any kind of information relevant to the task, like text, code, or specific instructions. This represents the desired outcome of the task that the generated prompt should trigger. It outlines the type of output expected from the language model, such as a summary of a text, a creative story, or a response to a question. Outputs: the result of this component is the generated prompt itself. It is designed to be used with a language model to perform the specified task and generate the desired outputs. Steps: the initial step involves understanding what task the prompt should facilitate. This might involve analyzing the input data and desired outputs to identify the specific action required. Once the task is identified, the component needs to determine which input data is relevant for the task and will be included in the prompt. This might involve selecting specific parts of the input or filtering out irrelevant information. The next step is to clarify the expected output format and style. This ensures that the generated prompt guides the language model to produce the desired output effectively. This step involves crafting the prompt itself. The prompt is structured to guide the language model to perform the specified task using the provided input data and generate the desired output. Prerequisites: the component needs a clear understanding of the task and its desired outcomes. This includes the specific action to be performed in the expected format and style of the output. Real-world examples include tasks like summarizing a document, answering questions based on a provided text, or generating creative text formats such as poems, scripts, or musical pieces. These tasks require a specific understanding of what the desired output should look like and what kind of information is relevant to achieve that outcome. Understanding the capabilities of the language model is crucial for generating effective prompts. This involves knowing the strengths and limitations of the specific model being used. Language models like GPT-3 and Jurassic 1 Jumbo are capable of performing a wide range of tasks. But they also have limitations. A prompt that works well with one model might not be effective with another. For instance, some models are better at generating creative text formats, while others excel at factual tasks like question answering. Understanding these nuances helps in crafting prompts that leverage the strengths of the model. Fine-tune parameters. Temperature is a parameter that controls the creativity and randomness of the generated prompt. A higher temperature value leads to more creative and unpredictable outputs, while a lower value produces more deterministic and predictable results. Top P is a parameter that controls the diversity and originality of the generated prompt. A higher top P value leads to more diverse and original outputs, while a lower value produces more predictable and familiar results. Challenges and fixes. A common challenge is that the generated prompt might be too ambiguous or unclear, leading to unpredictable outputs from the language model. To address this, the component should focus on rephrasing the prompt to be more specific and unambiguous. This can involve breaking down complex instructions into simpler steps, providing clear examples of the desired output, or explicitly defining the constraints of the task. Another challenge is that the prompt might be too short or too long. A too short prompt might lack sufficient context or instructions, while a too long prompt might overwhelm the language model with information. To solve this, the component should adjust the length of the prompt to ensure it is concise and informative. This can involve trimming unnecessary information or adding relevant context as needed. The prompt might not provide enough context to guide the language model accurately. To address this, the component should add relevant context to the prompt. This can involve including relevant information about the task, the domain of the input data, or the desired style of the output. The prompt might not specify the desired output format. To fix this, the component should specify the desired output format in the prompt. This can include instructions regarding the length, style, structure, or specific elements of the output. The prompt might not be tailored to the specific language model's strengths and limitations. The component should tailor the prompt to the specific language model's strengths and limitations. This can involve using specific keywords or phrasing that the model is known to respond well to, or avoiding language constructs that might confuse or overwhelm the model. Langchain Text Splitters Base Summary. This is an overview of the core functionalities and design of text splitters in langchain, a library designed to streamline interactions with large language models. LLMs. Text splitters are crucial for breaking down large bodies of text into smaller, more manageable units, making them suitable for processing by LLMs. Inputs. Text-to-split refers to the raw text data that needs to be segmented into smaller chunks. This could be a document, an article, or any other textual input. Parameters for splitting. These parameters are used to define how the text splitting process will be executed. These can include chunk size, the desired length of each individual chunk, overlap between chunks, the amount of text that should overlap between consecutive chunks, often employed to preserve context. Splitting criteria, specific rules or strategies to guide the text division, such as splitting at sentence boundaries or specific keywords. Outputs. List of text chunks. The output of a text splitter is a collection of smaller text segments. each representing a chunk of the original input. These chunks are then ready to be fed into an LLM for processing. Steps. Identify splitting criteria. The first step is to determine the rules or methods that will be used to split the text. These criteria could be based on predefined parameters, such as chunk size and overlap, or more sophisticated techniques like identifying sentence boundaries or specific keywords. Apply criteria to text. The splitting criteria are then applied to the input text. The text is scanned and divided into chunks according to the established rules. Generate list of chunks. The resulting chunks are collected and organized into a list, which can then be used for further processing, such as feeding them into an LLM for analysis or generation. Prerequisites. Text data. A text splitter requires text as its input. This could be in the form of a string, a file, or any other format that represents textual information. Fine-tune parameters. Chunk size. This parameter controls the length of each individual chunk produced by the text splitter. Larger chunk sizes result in fewer chunks, but each chunk might contain more information, potentially requiring more computational resources from the LLM. Smaller chunk sizes create more chunks, potentially reducing computational requirements but requiring more processing steps. Overlap between chunks. Overlap refers to the amount of text that is shared between consecutive chunks. Overlap is crucial for maintaining context between chunks, as LLMs may need information from previous chunks to understand the context of the current chunk. For example, imagine splitting a novel into chunks. An overlap of a few sentences between each chunk can help maintain the narrative flow and prevent the LLM from losing context. Challenges and fixes. Maintaining context between chunks. One challenge of text splitting is ensuring that the meaning and context of the original text are preserved across the generated chunks. For example, imagine splitting a document about a historical event. If a chunk ends mid-sentence, the LLM may misinterpret the context. Increase overlap between chunks. Increasing overlap helps to address this challenge by providing the LLM with more context from previous chunks, mitigating the risk of misinterpretation due to abrupt chunk boundaries. Splitting at inappropriate locations. Another challenge is avoiding splitting the text in ways that disrupt the flow of ideas or natural language constructs. For example, splitting a sentence in the middle can create grammatically incorrect or nonsensical chunks. Use more advanced splitting methods. This involves employing sophisticated algorithms that identify sentence boundaries, paragraph breaks, or even semantic boundaries to ensure that the text is divided in a way that preserves its meaning and flow. Producing uneven chunks. A potential issue is that the resulting chunks may be of unequal length, which can lead to inconsistent processing times for the LLM. Use more sophisticated algorithms. Employing algorithms that aim to generate chunks of relatively uniform size can help address this challenge. These algorithms may use techniques like identifying word boundaries, sentence lengths, or semantic relationships to achieve more balanced chunk sizes. Langchain experimental video captioning services. Caption service. Caption processor summary. Generate captions from a video by using a captioning model. This processor takes a video as input and utilizes a pre-trained model to generate a list of captions corresponding to each frame or segment in the video. Inputs: video URL or local video file path. This processor accepts video content from either a publicly accessible URL or a local file path on the system. For example, it can process a video hosted on YouTube or a video file stored on the user's computer. Outputs: list of captions for each frame or segment. The output of this processor is a list of text captions, each representing a specific frame or segment within the input video. The captions are generated based on the content of the corresponding video portion. Steps. Load the video file or URL. The first step involves accessing the video data, either by fetching it from the provided URL or by reading the local file. This step ensures the video content is available for processing. Process the video using the chosen model. The loaded video is then passed to a pre-selected video captioning model. The model analyzes the video content, identifying key elements and generating corresponding text descriptions. Generate captions for each frame or segment. Based on the analysis by the chosen model, the processor generates a list of captions. Each caption corresponds to a specific frame or segment within the video, providing a textual representation of the video's content. Prerequisites. Video captioning model. The processor requires a pre-trained video captioning model to perform the task. This model has been trained on a large dataset of videos and their corresponding captions, enabling it to understand and generate captions for new videos. Challenges and fixes. Model might not be accurate. The chosen video captioning model may not always provide perfectly accurate captions. The accuracy can depend on factors like video quality, the model's training data, and the complexity of the content. Fine-tune the model or use a different model. To improve accuracy, consider fine-tuning the model on a dataset more specific to the type of video being processed. Alternatively, explore using a different pre-trained model that might be better suited for the particular content. Model might not support all video formats. The video captioning model might have limitations in terms of the video formats it can process. For example, it might not support certain codecs or container formats. Convert the video to a supported format. If the video is in an unsupported format, convert it to a format compatible with the model. This might involve using video editing software or online tools to transcode the video to a supported format. Video might be too long for the model. The chosen video captioning model might have limitations on the maximum video duration it can process. Very long videos might exceed these limitations. Break the video into smaller segments. If the video is too long, divide it into smaller segments, each within the model's processing capacity. Process each segment independently and then concatenate the resulting captions to create a comprehensive caption list for the entire video. This step involves dividing the input text into smaller units based on the specified parameters, such as chunk size, chunk overlap, and separator. The text is split into chunks of the desired size with the specified amount of overlap. If a separator is provided, the text will be split at the separator boundaries to preserve natural textual structure. Return list of chunks. After splitting the text into chunks, this step returns a list of strings representing the generated chunks. Each string in the list corresponds to a single chunk of the input text. This list of chunks can be used as input to other langchain components or for any processing that requires the text to be divided into smaller units. Prerequisites. Text. The text splitter requires input text to split into chunks. This text can be any string or text data that needs to be processed in smaller units. For example, it could be a document, a news article, a book chapter, or any other textual content. Chunk size. The text splitter requires a chunk size parameter to determine the desired size of each chunk in tokens. Tokens are the basic units of text that language models process. The chunk size determines how many tokens will be included in each chunk. Fine-tune parameters. Chunk size. The chunk size parameter allows users to adjust the size of each chunk to optimize processing for different use cases. For example, if working with short texts, a smaller chunk size might be appropriate, while for long documents, a larger chunk size might be more efficient. Chunk overlap. The chunk overlap parameter allows users to control the amount of overlap between consecutive chunks. Overlap is useful for maintaining context and preventing information loss at chunk boundaries. A higher overlap value will result in more overlapping tokens between chunks, which can help to improve contextual understanding. Challenges and fixes. When the input text is too short to be split into chunks of the specified size, the text splitter should handle this situation appropriately. In this case, the text splitter should return the entire text as a single chunk to avoid creating empty or incomplete chunks. When the input text is too long to be split into chunks of the desired size, the text splitter should handle this situation appropriately. In this case, the text splitter should split the text into chunks that are as close to the desired size as possible, while ensuring that no chunk exceeds the specified chunk size limit. Langchain experimental taught prompts get caught prompt. The chain of thought caught prompt generator generates a prompt for a task that guides the language model to reason through the problem step by step. For example, the generator might ask the language model to first summarize the task, then identify the key concepts, and finally provide a solution. This process helps the language model to break down complex tasks into smaller, more manageable steps, leading to more accurate and coherent responses. Inputs. The input to the chain of thought prompt generator is the task to be completed. The task should be clearly defined and specific. For example, the task could be write a short story about a cat who goes on an adventure. Outputs. The output of the chain of thought prompt generator is a chain of thought prompt. The prompt is designed to guide the language model through a series of steps to complete the task. For example, a chain of thought prompt for the task write a short story about a cat who goes on an adventure might look like this. Think about a cat and what kind of adventure it might have. Now, write a story about that adventure. Remember to include details about the cat's personality and the challenges it faces. Steps. Identify the task to be completed. This step involves understanding the task and its requirements. For example, if the task is to write a short story about a cat who goes on an adventure, the generator needs to understand that the story should be about a cat, that the cat should go on an adventure, and that the story should be short. Break the task into smaller steps. This step involves breaking the task down into smaller, more manageable steps. For example, the task write a short story about a cat who goes on an adventure could be broken down into the following steps. Think about a cat and what kind of adventure it might have. Come up with a setting for the adventure. Write a story about the cat's adventure, including details about its personality and the challenges it faces. Generate a prompt that guides the model through each step. This step involves creating a prompt that guides the language model through each step of the task. For example, the prompt for the step think about a cat and what kind of adventure it might have could be what kind of cat would you like to write about? What kind of adventure might this cat go on? Prerequisites. The task should be clear and well defined. This means that the task should be specific and easy to understand. For example, the task write a story is not clear, while the task write a short story about a cat who goes on an adventure is clear. Fine-tune parameters. Number of steps to break the task into. This parameter controls how many steps the task is broken down into. For example, A larger number of steps might be used for more complex tasks, while a smaller number of steps might be used for simpler tasks. Level of detail in the prompt. This parameter controls how much detail is included in the prompt. For example, a more detailed prompt might include specific questions that the language model should consider, while a less detailed prompt might simply provide a general overview of the task. Challenges and fixes. Task is too complex to break down into manageable steps. For example, the task write a novel about the history of the world might be too complex to break down into manageable steps. Fix. Simplify the task or use a smaller number of steps. For example, the task write a short story about a cat who goes on an adventure is much simpler and easier to break down into manageable steps. The prompt is too long or difficult to understand. For example, a prompt that is several paragraphs long and includes a lot of technical jargon might be difficult to understand. Fix. Shorten the prompt or use more concise language. For example, instead of writing "What kind of cat would you like to write about?" What kind of adventure might this cat go on? Where might this adventure take place? What challenges might the cat face? What kind of personality does the cat have? What is the overall tone of the story? You could write "Think about a cat and what kind of adventure it might have." Now, write a story about that adventure. Langchain text splitters character recursive character text splitter. This langchain text splitter uses a recursive approach to break down a large text into smaller chunks of a specific size. It repeatedly splits the text until all resulting chunks are below the maximum allowed size. This strategy ensures manageable input sizes for language models while preserving context by maintaining some overlap between chunks. Inputs. A body of text that needs to be split into smaller pieces for processing. Outputs. A list of text chunks, each representing a section of the original input text, suitable for language model processing. Steps. The text is initially split into chunks based on the specified chunk size. For example, if chunk size is 100 characters, the text is divided into chunks of up to 100 characters each. Any chunks that exceed the defined chunk size are further split recursively until all chunks are smaller than the maximum size. This ensures that all chunks are manageable for language models. Prerequisites. Chunk size. The maximum allowable size of each resulting text chunk. This parameter determines how much text each chunk will hold. This value represents the maximum number of characters a single chunk can have. In the provided example, the maximum size of a chunk is 100 characters. This means that no chunk will be larger than 100 characters, even if a word or sentence spans across the chunk boundary. Fine-tune parameters. Chunk size. The maximum size of each chunk, measured in characters. Chunk overlap. This parameter defines how many characters should overlap between adjacent chunks. This overlap is crucial for maintaining context across chunks. Challenges and fixes. Splitting text that contains special characters, such as punctuation, symbols, or accented characters, can be tricky. These characters might break the logic of the chunk size parameter, potentially creating chunks that are either too short or too long. To address this, chunk overlap is introduced. It ensures that chunks do not split words or sentences in the middle by overlapping characters. This way, special characters are treated as part of the whole word or sentence and don't cause unexpected chunk boundaries. For example, if a chunk ends with the character, the overlap will ensure that the next chunk starts with the character, so "the" is not separated from the word or sentence. Splitting text that contains long words or sentences can also pose challenges. If a single word or sentence is longer than the chunk size, the splitter might need to split that word or sentence into multiple chunks. This can lead to fragmented text and disrupt the flow of the original text. To handle such scenarios, the chunk size parameter can be adjusted to accommodate long words or sentences. Increasing the chunk size allows the splitter to create larger chunks that can contain entire words or sentences, even if they are longer than the initial chunk size value. For example, if a word is 150 characters long, the chunk size parameter should be set to at least 150 characters to ensure that the entire word is contained within a single chunk. This adjustment preserves the integrity of the original text and maintains the context of a content. Langchain text splitters base token text splitter. Base class for all text splitters in langchain. Inputs. Text to be split. The text to be split is the input to the text splitter. This is the raw text which will be split into smaller chunks. Optional parameters to control the splitting logic. These parameters can be used to customize the splitting behavior. For example, you can specify the desired chunk size or the amount of overlap between chunks. Outputs. List of text chunks. The output of the text splitter is a list of text chunks. Each chunk is a portion of the original text that has been split based on the specified parameters. Steps. 1. Initialize the splitter with desired parameters. This step involves setting up the text splitter with the desired configuration, such as the chunk size and overlap. 2. Split the text into chunks. This is the core functionality of the text splitter, where the input text is divided into smaller chunks according to the defined parameters. Prerequisites. Text to be split. This is the raw text that needs to be split into smaller chunks. For example, this is a long text that needs to be split. Optional parameters to control the splitting logic. These parameters can be used to customize the splitting behavior. For example, you can specify the desired chunk size or the amount of overlap between chunks. For example, chunk size 100. Chunk overlap 10. Fine-tune parameters. Chunk size, the desired size of each chunk. This parameter specifies the number of characters in each chunk. It is a key parameter for controlling the length of the text chunks. Chunk overlap, the number of characters to overlap between chunks. This parameter controls the amount of overlap between adjacent chunks. Overlap can be helpful for ensuring that context is maintained across chunks. Challenges and fixes. Large texts take too long to split. This is a common challenge when splitting large texts. The processing time can become significant, especially if the text is very long. To address this, you can split the text in smaller batches. This can help to reduce the processing time and improve efficiency. Chunks may not be well-formed sentences. When splitting text, it is important to ensure that the resulting chunks are well-formed sentences. If the chunks are not well-formed, they can be difficult to process and understand. To address this, you can use a sentence splitter to ensure that chunks are complete sentences. This can help to improve the quality and readability of the split chunks. Langchain text splitters base language. Langchain text splitter base class description. This class provides the foundation for all text splitting functionalities within the langchain library. It serves as a blueprint for creating text splitters that divide large bodies of text into manageable chunks. These chunks are then processed by other components of langchain, enabling efficient and effective analysis of text data. Inputs. Text to split description. The input text that needs to be divided into smaller portions. This can be any text. such as a document, an article, or a book. Optional parameters to configure the splitting behavior description. This allows customization of the splitting process, such as specifying the desired chunk size, overlap between chunks, or any specific splitting rules. Outputs. List of text chunks description. The output of the text splitter is a list of text chunks, each containing a portion of the input text. These chunks are ready for further processing by other langchain components. Steps. Initialize the splitter with desired parameters. Description. The text splitter is first initialized with the provided parameters. This step sets up the configuration for the splitting process, allowing for customization of the splitting behavior. Split the input text into chunks. Description. Once initialized, the text splitter proceeds to divide the input text into chunks according to the specified parameters. Prerequisites. Text to split description. As mentioned earlier, a text splitter requires input text that needs to be divided into smaller portions. Python 3.7 or higher description. The text splitter requires Python 3.7 or a later version to function properly. Python 3.7 introduces several improvements and features that are necessary for the text splitters. Operation. Fine-tune parameters. Chunk size description. This parameter defines the size of each text chunk that will be generated by the splitter. It specifies the number of characters or words that will be included in each chunk. For example, a chunk size of 1000 would result in chunks containing 1000 characters each. Chunk overlap description. The chunk overlap parameter allows for specifying the amount of overlap between consecutive text chunks. This overlap helps maintain context across different chunks by ensuring that some text is repeated between adjacent chunks. For example, a chunk overlap of 50 would mean that each chunk shares the last 50 characters of the previous chunk. This can be useful for maintaining context in natural language processing tasks. Challenges and fixes. Handling text with special characters description. Special characters can pose challenges to text splitters, as they may affect the splitting process and lead to unintended results. For example, a text splitter might misinterpret a hyphen as a word boundary, resulting in incorrect chunk boundaries. This issue can be addressed by using character-based splitting approaches that consider special characters. Use a character-based splitting approach that considers special characters description. One solution is to use a character-based splitting approach that takes into account special characters. This approach treats each character as an individual unit and splits the text at character boundaries, ensuring that special characters are handled correctly. Maintaining context across chunks description. Maintaining context across different chunks is crucial for tasks that require understanding the relationships between different parts of the text. For instance, in text summarization, it is essential to maintain context to ensure that the summary accurately reflects the original text. Use a splitting strategy that ensures relevant context is preserved. Description. To address this challenge, text splitters can employ splitting strategies that prioritize the preservation of context. These strategies might involve splitting text at sentence boundaries or using techniques to identify meaningful context units, ensuring that the chunks maintain the flow of information. Langchain text splitters. Base text splitter summarization. Inputs. The input text that needs to be split into smaller chunks for further processing. This could be a document, a book, an article, or any other text format that is readable by the system. Optional parameter that specifies the desired size of each chunk in terms of characters, words, or sentences. If not provided, the splitter may use a default value or determine the chunk size based on The text itself. Optional parameter that specifies how much overlap should exist between consecutive chunks. Overlap can be useful for maintaining context when processing chunks sequentially. For example, an overlap of 10 characters would mean that the last 10 characters of one chunk would also be the first 10 characters of the next chunk. Optional parameter that specifies the delimiter or separator that should be used to split the text into chunks. This could be a specific character, a pattern, a regular expression, or even a custom function that defines the splitting criteria. Outputs. A list of text chunks created by splitting the input text according to the specified parameters. Each chunk in the list represents a portion of the original text and can be processed individually or collectively. Steps. The input text is divided into smaller segments or chunks based on the provided parameters such as chunk size, overlap, and separator. This step ensures that the original text is broken down into manageable units for further processing. The resulting list of text chunks is returned as the output of the splitter. This list represents the segmented text ready for processing by other components in the system. Prerequisites. The splitter requires the input text as a starting point for the splitting operation. Without the input text, there is nothing to split. Optional parameters such as chunk size, overlap, and separator provide the splitter with instructions on how to divide the text. These parameters allow for fine-tuning the splitting process to suit specific requirements. Fine-tune parameters. The desired size of each chunk in terms of characters, words, or sentences. This parameter influences the number of chunks generated and the amount of context preserved within each chunk. The amount of overlap between consecutive chunks. Overlap can be used to maintain context across chunks and reduce the risk of losing information at chunk boundaries. Challenges and fixes. Challenge 1. None. Fixes to challenge 1. A streaming approach allows the splitter to process the input text in a piecemeal fashion without loading the entire text into memory. This is especially useful for handling large files or data streams where memory constraints may be a concern. Challenge 2. None. Fixes to challenge 2. Using chunk overlap can help to maintain context across chunks by ensuring that some text is shared between adjacent chunks. This allows subsequent processing steps to have access to a broader context and make more informed decisions. Challenge 3. None. Fixes to challenge 3. Custom separators allow the splitter to split text based on specific criteria that are not necessarily character-based. This could involve splitting based on sentence boundaries, paragraph breaks, or even custom delimiters that are relevant to the specific text being processed. Challenge 4. None. Fixes to challenge 4. Adjusting the chunk size and overlap parameters can help to balance the trade-off between having a suitable chunk size for processing and generating a reasonable number of chunks. By carefully tuning these parameters, the splitter can ensure that the text is split effectively while also minimizing the overhead of processing a large number of chunks. Other parameters that can be specified include a custom regular expression regex pattern to use for splitting the text, a minimum chunk size, and a maximum chunk size. Fine-tune parameters. Chunk size is a key parameter that determines the length of each chunk. It can be adjusted based on the requirements of the specific application. For example, if the text is being used for training a machine learning model, a smaller chunk size might be preferable to ensure that the model can process the data efficiently. Chunk overlap is another important parameter that affects the way the text is split. It determines the amount of overlap between adjacent chunks. This can be useful for ensuring that no information is lost at the boundaries between chunks. For example, If you are using the text splitter to process a news article, you might want to set the chunk overlap to 50 to ensure that the important information at the end of one chunk is also captured in the beginning of the next chunk. Separator is used to define the specific character or pattern that the text splitter uses to split the text into chunks. By default, the text splitter uses whitespace as the separator. However, you can specify a custom separator if necessary, depending on the characteristics of the input text. For example, if your text document uses semicolons to separate sentences, you can specify a semicolon as the separator. Other parameters that can be used to fine-tune the splitting process include specifying a custom regular expression regex pattern to use for splitting the text, setting a minimum chunk size, and setting a maximum chunk size. Challenges and fixes. Text too long for memory. If the input text is too long to be processed by the memory of the application, the text splitter might encounter an error. In this case, reducing the chunk size can be a solution. By splitting the text into smaller chunks, the application can process the text more efficiently, avoiding memory issues. For example, if you are trying to split a very large book into chunks, you might need to reduce the chunk size from 500 words to 100 words to avoid memory errors. Text contains special characters. If the input text contains special characters, the text splitter might have difficulty splitting the text correctly. In this case, you can use a custom separator or a regular expression regex to specify how the text should be split. For example, if the text contains commas and semicolons as separators, you can specify a custom separator that includes both commas and semicolons. Alternatively, you can use a regex to specify a pattern that captures both commas and semicolons. Splitting results in unwanted chunks. If the text splitter produces unwanted chunks, you can adjust the chunk size or the chunk overlap. For example, if the text splitter is producing chunks that are too short, you can increase the chunk size. Conversely, if the text splitter is producing chunks that are too long, you can decrease the chunk size. Similarly, you can adjust the chunk overlap to control the amount of overlap between adjacent chunks. By fine-tuning these parameters, you can ensure that the text splitter produces chunks that meet your specific requirements. Langchain text splitters summarization. A description of how text splitters work in langchain. Inputs. Text: the text to be split into chunks. This could be a document, an article, a book, or any other type of text. Maximum chunk size: the maximum number of characters or tokens in each chunk. This is important for controlling the size of the input to a language model. Outputs. List of text chunks. The output of the text splitter is a list of text chunks. Each chunk is a smaller piece of the original text that is suitable for processing by a language model. Steps. Split text into smaller chunks. This is the core function of a text splitter. It takes a large piece of text and breaks it down into smaller chunks that are more manageable. Maintain context within each chunk. It is important to maintain context within each chunk. This means that the chunks should be logically connected and should not break up important relationships between the text. Prerequisites. Long text input. Text splitters are designed to work with long pieces of text. They are not suitable for splitting short pieces of text. Examples of long text inputs include large documents. These can be reports, research papers, legal documents, or other types of documents that are several pages long. Articles. These can be news articles, blog posts, or magazine articles. Books. These can be fiction or non-fiction books. Chunking requirement text splitters are often used to address the following requirements. Efficient processing. Breaking down large pieces of text into smaller chunks can make it easier for language models to process text. This can improve the speed and efficiency of processing. Model memory limits. Language models have limited memory. They can only process a certain amount of text at a time. Text splitters can help to break down text into chunks that are small enough to fit within the memory limits of a language model. Fine-tune parameters. Chunk size. This is one of the most important parameters to tune. It determines the size of the chunks that are generated. Overlap. The overlap parameter controls the amount of overlap between chunks. This is important for maintaining context between chunks. Challenges and fixes. Chunk size too small. If the chunk size is too small, the text will be split into too many chunks. This can make it difficult to understand the context of the text. The fix is to increase the chunk size. Chunk size too large. If the chunk size is too large, the text will be split into too few chunks. This can lead to a loss of context and can make it difficult for language models to process the text. The fix is to decrease the chunk size. Context loss. If the overlap between chunks is too small, context can be lost. This can make it difficult to understand the relationship between chunks. The fix is to increase the overlap. Summary of langchain text splitters. Colpi text splitter. A text splitter that splits Korean text into chunks based on the number of sentences. It leverages the Colpi library for sentence segmentation. Inputs. Text to be split. This could be a Korean news article, a blog post, or any other Korean language text that needs to be broken down into smaller, manageable chunks. Outputs. A list of text chunks. Each chunk in the list represents a portion of the original text, segmented based on the specified number of sentences. Steps. 1. Initialize Colpi text splitter with desired parameters. This involves setting the chunk size and chunk overlap parameters, which determine the number of sentences per chunk and the number of overlapping sentences between consecutive chunks, respectively. 2. Call the split method on the Colpi text splitter instance, passing in the text to be split. This triggers the sentence segmentation process, dividing the input text into chunks according to the configured parameters. Prerequisites. Colpi library installed. Colpi is a Python library that provides utilities for working with Korean text, including sentence segmentation. Make sure you have Colpi installed in your Python environment before using Colpi text splitter. Fine-tune parameters. Chunk size. The desired number of sentences per chunk. For example, if you want each chunk to contain 5 sentences, you would set chunk size to 5. Chunk overlap. The number of sentences to overlap between chunks. This parameter allows for smoother transitions between chunks and helps to avoid losing context at chunk boundaries. For instance, if you set chunk overlap to 2, the last 2 sentences of a chunk will be included in the beginning of the next chunk. Challenges and fixes. Challenge 1. Handling of long sentences. Long sentences can lead to chunks that are disproportionately large, potentially hindering downstream processing tasks. Fixes to challenge 1. Using a smaller chunk size. Reducing the chunk size parameter allows for the creation of more smaller chunks, effectively handling long sentences and ensuring that individual chunks remain manageable in size. Challenge 2. Handling of text with non-Korean characters. The Colpi library is specifically designed for Korean text processing. When encountering text with non-Korean characters, Colpi text splitter might not perform as expected, potentially leading to inaccurate sentence segmentation and incorrect chunk creation. Fixes to challenge to pre-processing text to remove non-Korean characters before splitting. Before feeding the text to Colpi text splitter, it is advisable to pre-process the text to remove any non-Korean characters. This can be achieved by using regular expressions or other text processing techniques to isolate and remove non-Korean characters. Removing these characters ensures that Colpi text splitter can accurately segment the Korean text and generate meaningful chunks. For example, if the text contains English words or symbols, these should be removed before splitting to avoid disruption in the sentence segmentation process. Langchain HTML text splitter summary. Breaking down HTML documents into smaller pieces, called chunks, to make them easier for language models to process. This is important because language models often have limitations on the amount of text they can handle at once. Inputs: the HTML content that needs to be split into chunks. This could be the raw HTML code of a web page or a file containing HTML. An optional parameter specifying how the HTML content should be divided. Common strategies include splitting based on the number of characters or sentences. Outputs: a list of text chunks. Each chunk contains a portion of the original HTML content, making it suitable for processing by a language model. Steps: the process begins by transforming the HTML input into a structured representation called a tree structure. This allows the system to understand the organization of the HTML content. The system then goes through each element of the HTML tree structure, extracting the text content from each element. Next, the extracted text is divided into chunks based on the specified splitting strategy. This ensures that each chunk is within the acceptable size limit for the language model. Finally, the resulting chunks are ready for processing by the language model. Prerequisites: a library that can pass HTML content into a structured representation. A popular choice for this task is the Beautiful Soup library, which provides tools for navigating and extracting data from HTML documents. A strategy for dividing the text content into chunks. One common strategy is to split the text based on the number of characters. Another option is to split based on sentence boundaries, ensuring that each chunk contains complete sentences. Fine-tune parameters: the size of each chunk, in terms of the number of characters or sentences. This parameter controls the granularity of the splitting process. The number of overlapping characters or sentences between adjacent chunks. Overlapping helps maintain context and prevents the loss of important information between chunks. Challenges and fixes: handling HTML elements that contain nested tags. A recursive approach can be used to traverse nested tags and extract the relevant text content. Maintaining the context of the original HTML content while splitting it into chunks. Overlapping chunks help preserve the context by ensuring that some information is shared between adjacent chunks. Splitting HTML content that contains errors or invalid markup. Robust error handling mechanisms and fallback strategies are necessary to handle these scenarios gracefully. Dealing with special characters, such as those used for formatting or encoding. Escaping or encoding special characters can ensure that they are properly handled during splitting and processing stages. Langchain text splitters LaTeX. Summary of Langchain text splitters for LaTeX code. Inputs: text to be split. This refers to the textual content that needs to be divided into smaller segments. LaTeX code: this represents the LaTeX code that accompanies the text. It provides structural and formatting information for the text. Outputs: List of text chunks. This refers to the output of the text splitter process. It is a list of text chunks, where each chunk represents a smaller segment of the original text. Steps. Split text into paragraphs using LaTeX commands. This step utilizes LaTeX commands to identify and extract paragraphs from the text. It leverages the structure and formatting information provided by the LaTeX code. Split paragraphs into chunks of desired length. Once paragraphs are extracted, they are further split into chunks of a specified length. This ensures that the text is broken down into manageable segments for processing. Prerequisites. LaTeX code must be valid. The LaTeX code used must be valid and adhere to the syntax rules of LaTeX. This ensures that the text splitter can accurately interpret the code and extract the intended structure. A valid LaTeX code would include commands such as section introduction. Text must be in a valid format. The input text must be in a format that the text splitter can handle. It should be plain text or text formatted with basic markup. For example, the text to split could be a scientific article or a research paper. Fine-tune parameters. Chunk size. This parameter determines the desired length of each text chunk. It controls the granularity of the text splitting process. For example, a chunk size of 500 words would result in chunks of approximately 500 words each. Chunk overlap. This parameter controls the amount of overlap between consecutive text chunks. Overlap is used to ensure that context is maintained across chunks. A chunk overlap of 100 words would mean that each consecutive chunk shares 100 words with the previous chunk. Challenges and fixes. Handling of complex LaTeX structures. The text splitter needs to be able to handle complex LaTeX structures, such as nested environments and multi-level headings. This might require the use of specialized libraries that are capable of parsing and understanding LaTeX code. For example, a specialized library for parsing LaTeX code could be used to handle nested environments or multi-level headings. Maintaining context across chunks. It is important to maintain context across chunks to ensure that the split text retains its meaning and coherence. This can be achieved by using overlap between chunks, where a portion of the previous chunk is included in the next chunk. This ensures that the context is carried over between chunks. For example, using overlap between chunks can ensure that the flow of information is not disrupted, and the meaning of the text is preserved. Langchain text splitters. LaTeX text splitter. This text splitter is specifically designed to handle LaTeX documents, dividing them into manageable chunks based on section headers. This approach allows for easier processing and analysis of large LaTeX documents, which are common in technical writing, scientific publications, and academic research. Inputs. A string containing a LaTeX document. This is the raw input that the text splitter will process. The LaTeX document can be a complex document containing multiple sections, subsections, and other LaTeX commands. Outputs. A list of LaTeX document chunks, each representing a portion of the original document. These chunks are delimited by section headers, ensuring that each chunk contains a cohesive unit of content, often representing a specific topic or subtopic. Steps. The first step in the process is to pass the LaTeX document into a hierarchical tree structure. This tree represents the logical organization of the document, with nodes for each section, subsection, and other LaTeX elements. The text splitter then iterates through this tree structure, identifying section headers. It splits the document at these headers, creating individual chunks that correspond to distinct sections. This ensures that the generated chunks are semantically meaningful and reflect the document's structure. Prerequisites. A valid LaTeX document is required as input for the text splitter to function properly. This document should follow LaTeX syntax and structure, allowing for accurate parsing and splitting. Fine-tune parameters. Chunk size represents the maximum number of characters allowed in each chunk. This parameter influences the length of the generated chunks, balancing the need for manageable chunk sizes with the goal of preserving meaningful units of content. Chunk overlap determines the number of characters that overlap between consecutive chunks. This overlap helps ensure that the context of the document is maintained across chunk boundaries, preventing information loss during processing. Challenges and fixes. Handling nested sections refers to the challenge of splitting LaTeX documents that contain multiple levels of nested sections. For instance, a document might have sections, subsections, and sub-subsections. To address this challenge, the text splitter employs a depth-first traversal of the tree structure. This ensures that the splitting process correctly identifies and splits sections at all levels, maintaining the document's hierarchical organization. Handling complex LaTeX commands refers to the challenge of distinguishing section headers from other LaTeX commands. LaTeX provides a wide range of commands for formatting, referencing, and other tasks, some of which might look similar to section headers. To address this, the text splitter uses a regular expression to accurately identify section headers while avoiding false positives from other LaTeX commands. This ensures that only the intended section headers are used as splitting points, preserving the integrity of the generated chunks. Langchain text splitters recursive character text splitter summarization. This text splitter divides a given text into chunks based on the character count. The recursive character text splitter is a tool that facilitates text processing by dividing large text into manageable portions. It is particularly useful for applications like summarization, question answering, and text classification, where processing large text chunks can be computationally expensive. Inputs. The input text that needs to be split into chunks of desired size. The size of each chunk in characters. This parameter determines the length of each chunk. The amount of overlap between consecutive chunks in characters. This overlap helps maintain context between chunks. Outputs. A list of text chunks that have been split from the original input text based on the specified parameters. Steps. The splitter iterates through the input text from the starting point. For each iteration, the splitter extracts a chunk of text with the specified size. If the remaining text is less than the chunk size, the remaining text is extracted as the final chunk. If chunk overlap is specified, the splitter overlaps the consecutive chunks by the amount specified. Prerequisites. A text to be split into chunks is required as input. Fine-tune parameters. Chunk size. This parameter determines the length of each chunk. The size of the chunk can be adjusted based on the task at hand and the length of the input text. Larger chunks can be used when processing long texts, while smaller chunks might be more suitable for shorter texts. Chunk overlap. This parameter controls the amount of overlap between consecutive chunks. It ensures that the context of the text is maintained across the chunks. A higher overlap might be beneficial for tasks that require more context, while a lower overlap might be appropriate for tasks where context is not as critical. Challenges and fixes. Challenge 1. Splitting text into chunks that are too small or too large. This challenge arises when the chunk size is not appropriate for the length of the input text or the specific task. Fixes to challenge 1. Adjust the chunk size and overlap parameters to achieve the desired chunk size based on the length. of the input text and the task requirements. For example, if the input text is a long article, larger chunks might be more suitable. On the other hand, if the input text is a short paragraph, smaller chunks might be more appropriate. Challenge 2: Splitting text that contains special characters. This challenge can arise when the input text contains special characters like punctuation marks, symbols, or emojis. Fixes to challenge 2: ensure that the chunk size and overlap parameters are set appropriately to handle special characters. In some cases, it might be necessary to adjust the chunk size or overlap to ensure that special characters are not split in the middle. This might require analyzing the distribution of special characters in the input text. Recursive character text splitter summarization. This YAML snippet provides a comprehensive description of the Markdown line type text splitter, a component within the langchain framework. It details the splitter's purpose, inputs, outputs, steps involved in its operation, prerequisites, fine-tuning parameters, and challenges encountered along with their corresponding solutions. This text splitter divides a given text into chunks based on Markdown line breaks. It utilizes the inherent structure of Markdown to create meaningful segments, preserving the formatting and logical flow of the original text. Inputs: text to be split into chunks. It can be a document, article, or any other text containing Markdown formatting. For example, a blog post containing headings, paragraphs, and code blocks. Desired size of each chunk in terms of the number of lines. This parameter dictates how many Markdown lines are grouped together to form a single chunk. A larger chunk size can help preserve context across chunks, but may lead to longer processing times. Outputs: list of text chunks generated from the input text. Each chunk is a self-contained portion of the original text, retaining its Markdown formatting and preserving the intended structure. Steps: identifies Markdown lines within the input text. This involves analyzing the text and recognizing the various Markdown elements, such as headings, paragraphs, lists, and code blocks. The presence of Markdown line breaks, which delimit different elements, is particularly significant. Groups identified Markdown lines into chunks based on the specified chunk size. This step involves aggregating the recognized lines into units of the defined size. The process ensures that each chunk remains cohesive and retains the original formatting and structure. Returns a list of text chunks, each representing a segment of the input text. These chunks, derived from the original text, maintain the formatting and logical flow while adhering to the specified chunk size. Prerequisites: text that is to be split into chunks. This text should be in Markdown format, allowing the splitter to effectively recognize and leverage the inherent structure. An integer indicating the desired size of each chunk. This parameter specifies the number of lines that will be grouped together to form a single chunk. A larger chunk size can be beneficial for preserving context across chunks, but it may lead to longer processing times. Fine-tune parameters. No fine-tuning parameters are available for this text splitter. It operates based on the provided text and chunk size, without requiring any specific configurations. Challenges and fixes. Handling nested Markdown elements. Nested Markdown elements, such as lists within lists, can pose a challenge for splitting the text into coherent chunks. This issue can be addressed by utilizing regular expressions to effectively parse the complex Markdown structures and ensure that chunks are correctly formed even in the presence of nesting. Splitting on line breaks within code blocks. Code blocks, while utilizing line breaks, are not intended to be separated. To avoid unintended splitting, the splitter should ignore line breaks within code blocks. This ensures that the code blocks remain intact and their formatting is preserved within pay. Generated chunks. Maintaining context across chunks. Contextual information can be lost if the chunk size is too small, particularly in cases where ideas span multiple lines. To address this, a larger chunk size can be utilized. This approach helps maintain the flow of ideas and ensures that the generated chunks provide a comprehensive representation of the original text. Langchain text splitters markdown. Description of the tool. Langchain text splitters markdown is a tool that enables splitting extensive text documents into smaller segments for enhanced processing. This functionality proves advantageous for tasks involving summarization, question answering, and text generation. Description of the tool inputs. The text document that needs to be broken down into smaller parts. The settings defining how the document should be divided. Description of the tool outputs. A compilation of text segments. Description of the tool steps. Retrieve the text document. Divide the text document into segments based on the specified configuration. Present the collection of text segments. Description of the tool prerequisites. Installing the langchain library using the package installer for Python. Pip install langchain. Importing the necessary classes from the langchain library. From langchain, text splitter import markdown text splitter. Defining the text document that will be segmented. Description of the tool fine-tune parameters. Chunk size. This parameter determines the maximum size of each segment. Measured in tokens. Tokens are the fundamental units of text in natural language processing (NLP). Chunk overlap. This parameter defines the number of tokens that are shared between consecutive segments. Overlapping helps maintain context between segments. Separators. This parameter is a list of delimiters or markers used to split the text. The separators indicate where the document should be divided into chunks. Description of the tool challenges and fixes. The text document might not be divided into segments of uniform size. Utilize the chunk overlap parameter to regulate the size of the segments. The text document may not be divided at appropriate points. Adjust the separators to ensure that the text is split at suitable locations. The text document may not be segmented into a sufficient number of chunks. Modify the chunk size to reduce the size of each segment. Langchain text splitters markdown header text splitter. The markdown header text splitter is a text splitter designed to divide a markdown document into smaller, manageable chunks using markdown headers as delimiters. This allows for easier processing and analysis of large markdown files by breaking them down into distinct sections. Inputs. A markdown document is the input for the markdown header text splitter. It can be a file or a string containing markdown content. Outputs. The output of the markdown header text splitter is a list of chunks, where each chunk represents a section of the markdown document delimited by a header. Steps. The first step involves identifying headers within the markdown document. The splitter analyzes the document and identifies headers using a specified pattern. Once headers are identified, the markdown document is split into chunks based on these headers. Each chunk starts with a header and ends with the next header or the end of the document. Prerequisites. The markdown document must be valid and contain headers for the splitter to function properly. Headers within the markdown document must follow a specific format as defined by the header pattern. Parameter. This ensures the splitter can correctly identify headers and perform the splitting operation. Fine-tune parameters. The max chunk size parameter controls the maximum size of each chunk. This allows for fine-tuning the size of the output chunks based on specific processing requirements. The overlap parameter allows for controlling the amount of overlap between chunks. This can be useful for ensuring context is maintained across chunks when processing the split data. Challenges and fixes. Incorrectly identifying headers can occur if the specified header pattern does not match the actual format of headers in the Markdown document. To resolve this, ensure the header pattern parameter accurately reflects the format of headers in the document. This can involve adjusting the pattern to match the specific header structure, such as using a regular expression to account for variations. Splitting into excessively large chunks can be an issue if the max chunk size parameter is set too high. Adjusting the max chunk size parameter to a smaller value can effectively control the size of each chunk. This allows for generating smaller and more manageable chunks, suitable for specific processing tasks. Overlapping chunks can arise if the overlap parameter is not set appropriately, leading to redundant information across multiple chunks. Adjusting the overlap parameter to control the amount of overlap between chunks can mitigate this issue. This allows for optimizing the balance between maintaining context and avoiding redundancy in pay. Output chunks. Langchain text splitters. LaTeX text splitter. Summary. A description of the LaTeX text splitter component in a larger system that processes LaTeX documents. This component is designed to divide LaTeX documents into smaller, more manageable chunks based on logical sections, like chapters, sections, and subsections. Inputs. A LaTeX document provided as a string of text. This string represents the entire LaTeX document, including all its content, formatting, and commands. Outputs. A list of text chunks, each representing a logical section from the LaTeX document. These chunks are extracted based on the identified section boundaries within the document. Each chunk preserves the formatting and equations from the original LaTeX document, maintaining its structure and appearance. Steps. The LaTeX text splitter component first parses the provided LaTeX document to identify the boundaries of logical sections. This parsing process involves recognizing specific commands like chapter, section, and subsection, which define the start of different sections within the document. Once the section boundaries are identified, the component extracts the text content within each section. This extraction process preserves the LaTeX formatting and equations present in the original document. For example, equations written using LaTeX syntax, like begin equation and end equation, are preserved within the extracted chunks. This ensures that the content of each chunk accurately reflects the formatting and structure of the original section. Prerequisites. A LaTeX document is required as input for the LaTeX text splitter to operate. The document should be in a valid LaTeX format and can include various LaTeX commands for formatting, structure, and equation rendering. Fine-tune parameters. Chunk size. This parameter determines the maximum length of each extracted text chunk. For instance, setting chunk size to 500 would result in text chunks no longer than 500 characters. This parameter allows for controlling the granularity of the splitting process, enabling users to adjust the size of the chunks based on their specific needs. Chunk overlap. This parameter specifies the amount of overlap between consecutive text chunks. For example, a chunk overlap of 100 would mean that each chunk overlaps with the previous chunk by 100 characters. This overlap can be helpful for ensuring that the context of the text is preserved across chunk boundaries, preventing sudden breaks in the flow of information. Challenges and fixes. Handling complex latex structures. Like nested sections or environments, the splitter encounters challenges when dealing with complex latex structures, such as nested sections or environments that may have multiple levels of nesting. These structures require careful parsing to accurately identify and handle the different levels of sectioning. The splitter addresses this challenge by leveraging a robust latex parser. This parser is designed to accurately identify and handle complex structures, ensuring proper section delimitation. The parser is able to navigate through nested sections and environments, correctly identifying the boundaries of each section and preserving the intended hierarchy of a document. Preserving latex formatting and equations within extracted chunks. Another challenge is preserving the original latex formatting and equations within the extracted chunks. This requires handling latex commands and special characters correctly, ensuring that the extracted chunks maintain the visual and structural integrity of the original document. The splitter tackles this challenge by employing a LaTeX-aware parser. This parser is specifically designed to retain latex syntax and special characters, such as mathematical symbols, within the extracted chunks. By using this parser, the splitter ensures that the extracted chunks preserve the formatting and equations present in the original document, maintaining the fidelity of the latex content. Langchain text splitters base split text on tokens. The text splitter class serves as a core component in langchain, enabling the efficient processing of large textual datasets by dividing them into manageable chunks. Inputs. Text to split. This refers to the input text that the text splitter will process and divide into smaller segments. For example, a lengthy article, a book chapter, or a collection of blog posts. Optional parameters for splitting. These parameters allow you to customize the splitting process, influencing factors like the size of the chunks, the amount of overlap between them, and other splitting strategies. This provides flexibility for tailoring the splitting to your specific application's needs. Outputs. List of text chunks. The output of the text splitter is a list of text chunks, each representing a portion of the original input text. These chunks can then be processed individually by other components in langchain, such as language models or retrieval systems, enabling parallel processing and improved efficiency. Steps. 1. Initialize text splitter object with parameters. The first step involves creating an instance of a text splitter class, specifying the desired splitting parameters. This configuration determines the behavior of the text splitter. 2. Call split method with text to split. Once the text splitter object is initialized, you call the split method, passing the input text to be divided into chunks. This method executes the splitting process, producing the list of text chunks as output. Prerequisites. Text. This refers to the textual data that needs to be split. It can encompass various forms of text, including articles, books, code, emails, or any other text-based content. Chunk size. This parameter specifies the desired length of each individual text chunk that will be produced by the text splitter. The chunk size should be chosen considering the limitations of the downstream processing components and the desired level of granularity in the analysis. Fine-tune parameters. Chunk size. This parameter, as discussed earlier, determines the desired length of each individual text chunk. The choice of chunk size will impact the number of chunks produced and the granularity of a analysis. Chunk overlap. This parameter controls the amount of overlap between consecutive text chunks. This overlap is often employed to maintain context between adjacent chunks. which can be crucial for tasks involving understanding relationships across textual segments. A larger overlap preserves more context but results in more redundancy in the chunks. Challenges and fixes. Handling text longer than chunk size when dealing with input text that exceeds the specified chunk size. The text splitter must handle the division effectively. This typically involves splitting the text into multiple chunks, ensuring that the original content is preserved without introducing significant fragmentation. Maintaining context between chunks to preserve the coherence and meaning of the original text. Maintaining context across chunks is essential, particularly for applications like text summarization or question answering. This is achieved through techniques like using chunk overlap, where a portion of the preceding chunk is included in the subsequent chunk. Summary of langchain text splitters. Character text splitter. The character text splitter divides text into chunks based on the number of characters in each chunk. This splitter is useful for breaking down large blocks of text into manageable portions for processing. For example, by a language model. Inputs. The input text that needs to be divided into chunks. The number of characters desired in each chunk. Outputs. A list of text chunks, where each chunk contains the specified number of characters. Steps. The character text splitter iterates through the input text character by character. It creates chunks of text, each containing the specified number of characters. Prerequisites. The input text is required for the splitter to function. Fine-tune parameters. Chunk size. The number of characters to include in each chunk of text. For instance, a chunk size of 1000 would result in chunks containing 1000 characters. Chunk overlap. This parameter specifies the number of characters that should overlap between adjacent chunks. Overlapping chunks can help ensure that context is preserved when processing the text. Challenges and fixes. Splitting text in the middle of a sentence can lead to incomplete thoughts or grammatical errors. A word-based splitter, which divides the text based on word boundaries, can be used to avoid splitting sentences. Splitting text without spaces, such as code or a long sequence of numbers, can result in chunks that are difficult to understand. In such cases, increasing the chunk size for the character text splitter can help ensure that the chunks are meaningful. For example, a chunk size of 20 or 30 characters could be suitable for code or a sequence of numbers. Langchain text splitters. Latex text splitter. Description of the latex text splitter. Inputs. Text. The text to be split into chunks. Latex document. The latex document to be converted into text and then split into chunks. The latex document is used as the raw input to the splitter and is converted to text using the latex to text library. Outputs. List of text chunks. The output of the splitter is a list of text chunks, where each chunk represents a section of the original text. The number of chunks depends on the parameters used to split the text, such as chunk size and overlap. Steps. Convert latex document to plain text. The first step in the process is to convert the latex document to plain text. This is done using the latex to text library. Split text into chunks using provided parameters. The second step is to split the text into chunks. This is done using the parameters provided to the splitter, such as chunk size and overlap. Chunk size specifies the maximum length of each chunk, while overlap specifies the amount of overlap between consecutive chunks. Prerequisites. Latex document. Any latex document can be used as input to the latex text splitter. The document is then converted to plain text using the latex to text library. Any LaTeX document. A LaTeX document is a document that uses the LaTeX markup language to format text and create documents. It can contain text, images, tables, and other elements. A document can contain any kind of content, including scientific articles, books, reports, and presentations. For example, a LaTeX document for a scientific article might contain text describing the research, figures, tables, and references. Python library. The LaTeX2 text library is required to convert the LaTeX document to plain text. It is a Python library that provides a simple API for converting LaTeX documents to plain text. LaTeX2text. LaTeX2text is a Python library that provides a simple application programming interface for converting LaTeX documents to plain text. It can be installed using the pip package manager. This library helps to convert LaTeX documents to plain text, allowing for easier processing and analysis of the text content. For example, using LaTeX2text, you can easily extract the text from a LaTeX document and then process it using natural language processing (NLP) techniques, such as sentiment analysis or topic modeling. Fine-tune parameters. Chunk size. The maximum length of each chunk. It is a positive integer that determines the maximum number of characters or words per chunk. Chunk overlap. The amount of overlap between consecutive chunks. It is a positive integer that determines the number of characters or words that are repeated in consecutive chunks. Challenges and fixes. Error in LaTeX to text conversion. Errors can occur during the conversion of LaTeX to plain text. This could be due to issues with the LaTeX document itself, the LaTeX2text library, or the environment in which the conversion is taking place. Install required LaTeX library. The LaTeX2text library is required to perform the conversion. Ensure that the library is installed correctly and that its dependencies are met. You can use pip to install the LaTeX2text library. Pip install LaTeX2text. Incorrect splitting. The text may be split incorrectly if the parameters for chunk size and overlap are not set appropriately. For example, setting the chunk size too small might result in too many small chunks, while setting it too large might result in too few large chunks. Adjust chunk size and overlap. Experiment with different values for chunk size and overlap to find the optimal settings for your use case. You can also adjust the chunk size based on the content of the document. For example, if you are splitting a document with a lot of headings and subheadings, you might want to set a larger chunk size to ensure that each chunk contains at least one heading. Summary of langchain text splitters. Python code text splitter. Inputs. Text input. Text to be split into chunks for summarization. This can be any textual data, such as news articles, blog posts, or scientific papers. Optional separator and optional delimiter to use for splitting the text. If not provided, the default sentence splitter from NLTK will be used. Outputs. List of chunks. A list of text chunks, each containing a specified number of words and potentially overlapping with other chunks. Steps. 1. Tokenizes input text using NLTK. The input text is first broken down into individual words or tokens using NLTK's tokenization capabilities. 2. Splits tokenized text using provided separator or a default sentence splitter. The tokenized text is then split into chunks based on the provided separator or the default sentence splitter, if no separator is provided. 3. Returns a list of chunks. The resulting chunks are returned as a list, ready for further processing, such as summarization. Prerequisites. NLTK library. The Natural Language Toolkit (NLTK) is a Python library essential for this process. It provides the necessary functionalities for text tokenization and sentence splitting. NLTK download. This command downloads the sentence tokenizer model from NLTK, which is used for splitting text into sentences. This model is crucial for accurate sentence segmentation, a key component of the text splitting process. Sentence splitter. The sentence splitter is a crucial component for accurately splitting the text into meaningful segments. The NLTK library provides a pre-trained sentence splitter, which uses a statistical model to identify sentence boundaries. NLTK data load tokenizers. English pickle. This command loads the pre-trained sentence splitter model for the English language, enabling the system to identify sentence boundaries within the input text. This model is trained on a large corpus of English text and can effectively handle various sentence structures and punctuation patterns. Fine-tune parameters. Chunk size. Number of words per chunk. This parameter controls the length of each text chunk. It specifies how many words should be included in each chunk. By adjusting this parameter, you can control the granularity of text splitting, allowing you to create chunks of varying sizes depending on your needs. For instance, you might use a smaller chunk size for detailed analysis or a larger chunk size for high-level summaries. Chunk overlap. Number of words to overlap between chunks. This parameter determines the extent of overlap between consecutive text chunks. By setting this parameter, you can ensure that important information is not lost at the boundaries of chunks. For example, a larger overlap can help preserve contextual information and prevent sentence fragments from appearing in the resulting chunks. Challenges and fixes. Challenge 1. Splitting text into chunks of inconsistent length. A common issue in text splitting is the creation of chunks with inconsistent lengths, which can negatively impact the analysis or summarization process. Fixes to challenge 1. Use a consistent chunk size parameter. Using a consistent chunk size parameter ensures that all chunks are of the same length, promoting uniformity and consistency in the analysis. This approach helps avoid the issue of having some chunks significantly longer or shorter than others, which can distort the results. Challenge 2. Splitting text at inappropriate places. Another challenge in text splitting is the potential for the splitting algorithm to divide the text at inappropriate places, leading to fragmented sentences or meaningful units of information being split across multiple chunks. Fixes to challenge 2. Define a suitable separator or adjust chunk overlap. Defining a suitable separator can help ensure that the text is split at meaningful boundaries, while adjusting the chunk overlap can help preserve contextual information. For example, using a paragraph break as a separator can result in chunks that align with natural breaks in the text, while a larger chunk overlap can help bridge the gaps between chunks and avoid disrupting the flow of information. Sentence Transformers Token Text Splitter Summary. A description of the Sentence Transformers Token Text Splitter. This class splits text into chunks based on sentence boundaries using a sentence transformer model. This means that it uses a pre-trained model to identify the sentences within a text and then splits the text into chunks based on those boundaries. Inputs. The input to the sentence transformer's token text splitter is the text to be split. This can be a string, a list of strings, or a file. For example, you might pass in a news article, a blog post, or a book chapter. Outputs. The output of the sentence transformer's token text splitter is a list of text chunks. Each chunk is a portion of the input text that is bounded by sentence boundaries. The length of each chunk is determined by the chunk size parameter. Steps. The first step in using the sentence transformer's token text splitter is to initialize it with a model name. The model name specifies which sentence transformer model to use for identifying sentence boundaries. There are many different sentence transformer models available, and the best model to use will depend on the specific task. The second step in using the sentence transformer's token text splitter is to split the input text into chunks using the model. This is done by calling the split method of the sentence transformer's token text splitter object. The split method takes the input text as an argument and returns a list of text chunks. Prerequisites. To use the sentence transformer's token text splitter, you need to have a sentence transformers model installed. The AlmpiNet-based 2 model is a popular and effective choice. You can download and install this model using the sentence transformers library. For example, you can use the following command: bash pip install sentence transformers. You also need to have the langchain library installed. The langchain library provides a set of tools for working with language models, including the sentence transformer's token text splitter. You can install langchain using the following command: bash pip install langchain. Fine-tune parameters. The chunk size parameter specifies the desired size of each text chunk. This parameter determines the number of sentences that will be included in each chunk. For example, if chunk size is set to 10, then each chunk will contain 10 sentences. The chunk overlap parameter specifies the amount of overlap between adjacent text chunks. This parameter determines how many sentences will be included in both the current and the previous chunk. For example, if chunk overlap is set to 2, then the last 2 sentences of the previous chunk will also be included in the current chunk. Challenges and fixes. If the sentence transformers model is not available, you will need to install it before using the sentence transformers token text splitter. You can install the model using the sentence transformers library. If an error occurs during the splitting process, you should check the sentence transformers model and the input text. For example, you should make sure that the model is correctly installed and that the input text is in a format that the model can process. Langchain text splitters Python code text splitter summary. This text splitter is designed to divide Python code into smaller, manageable chunks. The primary goal is to facilitate effective processing and analysis of the code. Inputs. A string containing Python code that needs to be divided into smaller units. For example, you could provide a function definition, a class implementation, or a complete program. Outputs. A list of code chunks. Each element in the list represents a section of the original code, broken down according to the specified splitting criteria functions. Classes. Steps. The text splitter first analyzes the provided Python code to identify all defined functions and classes. This process involves parsing the code and recognizing keywords like def for functions and class for classes. Once the function or class definitions have been identified, the text splitter uses them as boundaries to split the code into individual chunks. This ensures that each chunk represents a logically distinct unit of code, typically a function or a class. Prerequisites. LangChain is a framework that provides tools for building and deploying language models. The Python code text splitter relies on LangChain to provide the necessary functionalities for parsing and splitting the code. This placeholder is for additional prerequisites that might be necessary for the Python code text splitter to function correctly. For example, It could depend on a specific parser library or other tools for code analysis. Fine-tune parameters. The chunk size parameter defines the maximum size of each code chunk. This allows you to control the granularity of the code splitting. For example, a larger chunk size will result in fewer larger chunks, while a smaller chunk size will produce more smaller chunks. The chunk overlap parameter specifies the number of lines of code that should overlap between adjacent chunks. This can be useful for preventing important contextual information from being lost when the code is split. For example, a chunk overlap of 5 will ensure that the last 5 lines of one chunk are included in the beginning of the next chunk. Challenges and fixes. Handling nested functions is a challenge that the text splitter must address. This refers to situations where a function definition is contained within another function definition. To handle this, the text splitter uses a recursive approach. When a nested function is encountered, it splits the nested function into its own chunks and then continues splitting the surrounding function. This ensures that all functions, including nested ones, are split into separate chunks. Complex code structures can pose additional challenges for the text splitter. This might include scenarios where the code uses advanced programming constructs or non-standard syntax. To handle complex code structures, the text splitter can leverage advanced parsing techniques. This might involve using sophisticated code analysis libraries or implementing custom parsing rules to accurately identify function and class definitions even in non-standard code. Langchain text splitters sentence transformers token text splitter. The sentence transformers token text splitter is a text splitting component that breaks down large text documents into smaller, more manageable chunks. It leverages the power of sentence transformers, a model specifically designed to generate meaningful sentence embeddings. These embeddings capture the semantic relationships between sentences, enabling the splitter to divide the text intelligently. Inputs. Text to be split. This refers to the raw text document that needs to be processed and divided into chunks. For example, this could be a lengthy article, a book chapter, or a collection of news articles. Model name. This parameter specifies the name of the sentence transformers model to be used for embedding generation. This choice influences the quality of the sentence embeddings and ultimately impacts the effectiveness of the text splitting process. Common model names include ALMP Base 2 and ALDISTIL Roberta v1. Outputs. List of text chunks. The output of the sentence transformers token text splitter is a list of text chunks. Each chunk represents a meaningful segment of the original text, capturing coherent ideas or units of information. These chunks can then be used for various downstream tasks, such as summarization, question answering, or knowledge retrieval. Steps. Load sentence transformers model. The first step involves loading the specified sentence transformers model into memory. This model will be responsible for generating sentence embeddings. Tokenize text. The text is then tokenized, breaking it down into individual words or subword units. Tokenization is a crucial step in natural language processing (NLP), allowing the model to process the text effectively. Split text into chunks based on the generated sentence embeddings. The sentence transformers token text splitter divides the text into chunks. The algorithm considers the semantic relationships between sentences, aiming to create coherent and meaningful units of text. Prerequisites. Sentence transformers model installed. To use the sentence transformers token text splitter, you need to ensure that the desired sentence transformers model is installed in your Python Environment. This can be achieved using the command pip install sentence transformers. Common sentence transformers models include ALMPnet Base v2 and ALDISTIL Roberta v1. These models are trained on large datasets and have proven capabilities in generating robust sentence embeddings. Tokenization library installed in addition to the sentence transformers model. You need the transformers library installed. This library provides essential tokenization functionality, enabling the text to be broken down into individual words or subwords, preparing it for processing by the sentence transformers model. Fine-tune parameters. Chunk size. This parameter allows you to control the size of the text chunks generated by the sentence transformers token text splitter. You can adjust it to match the specific needs of your downstream task. For example, if you are performing summarization, you might want smaller chunks, while for question answering, larger chunks might be more appropriate. Chunk overlap. Chunk overlap refers to the amount of text that is included in multiple consecutive chunks. This parameter can be useful to ensure that context is preserved across chunk boundaries. By setting a small overlap, you can minimize the risk of losing crucial information as the text is split. Challenges and fixes. Model unavailable. If you encounter the error model unavailable, it means that the specified sentence transformers model is not installed in your environment. The fix is straightforward. Install the required model using pip install sentence transformers. Error during tokenization. If you encounter errors during the tokenization process, it might be due to an incompatible version of the transformers library. The recommended approach is to check the current version of the transformers library and ensure that it is compatible with the sentence transformers model you are using. If necessary, install the compatible version using the appropriate pip install transformers command.